DevOps is one of the most heard buzzwords in the IT industry, and it is a relatively new concept gaining popularity. DevOps represents a shift in traditional IT culture, emphasizing collaboration, automation, and continuous improvement. DevOps specialists who can assist companies in navigating the complex, fast paced world of software development and IT operations are in high demand today. Accenture, TCS, IBM, Cognizant, and HCL Tech are the top companies hiring for DevOps engineer roles. Today, let's explore what DevOps is and the differences between traditional IT and DevOps. We will explore the DevOps workflow, the different phases of the DevOps lifecycle, and the DevOps use cases, followed by the roles and responsibilities of a DevOps engineer, the skills required, and the basic qualifications to land a career in DevOps. Next, I will discuss some important tools used by a DevOps engineer. Finally, we will explore the importance of CI/CD and Jenkins and also demonstrate the installation of Jenkins and how to build a CI/CD pipeline in Jenkins. So before we get started with the topic, please consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content by Edureka. Also, visit the Edureka website for training and certification courses, the link to which is in the description box below. Now let's find out what exactly is DevOps. So DevOps is a set of practices that aims to automate and integrate software development and IT operations processes. The term DevOps is a combination of development and operations, reflecting the collaboration and communication between these two traditionally separate teams. The infinity symbol is often associated with DevOps as a representation of the continuous and iterative nature of the DevOps lifecycle. DevOps is a holistic approach that aims to develop a culture of cooperation and continuous improvement while automating procedures. The end goal is to deliver high-quality software faster and more reliably to meet the demands of today's fast-paced digital landscape. In 2008, the term DevOps was officially coined by Patrick Debois, a Belgian consultant, and Andrew Schaffer, a system administrator. The concept of DevOps emerged as a response to the challenges and inefficiencies that arose from the traditional approach to software development and IT operations. How is DevOps different from traditional models? DevOps differs from traditional models of software development and IT operations in several key ways. Traditional models often involve separate and distinct phases for development and operation, with less emphasis on collaboration, automation, and continuous delivery. Here are some of the key differences between DevOps models and traditional models. Development and operations teams often work in separate departments, leading to communication barriers and delays in the software delivery process. DevOps focuses on collaboration and communication between the operations team, development team, and other stakeholders. Teams work together throughout the entire development lifecycle, fostering a culture of shared responsibility. Traditional models rely heavily on manual processes for tasks like code deployment, testing, and infrastructure provisioning. This manual approach is time-consuming and is also prone to errors. DevOps advocates for automation at every stage of the development lifecycle. Automation tools and scripts are used to streamline and accelerate processes, reducing the risk of human errors and increasing efficiency. Traditional models often follow a waterfall model with sequential phases. Changes are not frequently released, leading to longer development lifecycle, whereas DevOps embraces continuous delivery, where incremental changes are delivered frequently. This enables organizations to meet customer needs, release new features, and resolve problems more quickly. Traditional models involve manually managing and configuring infrastructure, which can result in inconsistencies and difficulties in reproducing code environments. Whereas DevOps utilizes infrastructure as code principles, allowing for the automated provisioning and management of infrastructure. This ensures consistency across different environments and facilitates scalability. For traditional models, testing is often performed in isolated phases, leading to delays in identifying and addressing integration issues. DevOps adopts continuous integration, where developers integrate code changes regularly, triggering automated tests. This helps identify and fix integration issues early in the development process. Monitoring may be limited and issues may not be detected until they impact users or systems, whereas DevOps emphasizes continuous monitoring to detect and address issues in real time. This proactive approach helps maintain system reliability and provides valuable feedback for continuous improvement. In summary, DevOps represents a departure from the traditional models by promoting collaboration, automation, continuous delivery, and a cultural shift towards shared responsibility. These differences enable organizations to deliver software faster, more reliably, and with greater adaptability to changing requirements. DevOps Workflow. A DevOps workflow typically consists of several key stages, each playing a crucial role in the software development and delivery process. Here are four fundamental parts of a DevOps workflow. Continuous integration. Continuous integration is a software development practice that involves regularly integrating code changes from multiple contributors into a shared repository. The main goal of CI is to detect and address integration issues early in the development process, promoting a more collaborative and efficient workflow. Continuous testing. Automated CI processes are triggered whenever developers push code changes to the version control system. So CI involves building and testing the application to ensure that the new code integrates successfully with the existing code base. Continuous delivery is a software development practice that extends the principles of continuous integration to ensure that code changes are not only integrated and tested, but also automatically prepared for release and deployment. The ultimate goal of continuous delivery is to enable continuous and reliable delivery of software to production. Continuous deployment automates the process of deploying code changes to different environments such as development, testing, staging, and production. So CD pipelines define the steps involved in deploying applications, and they may include tasks like packaging, provisioning, infrastructure, and deploying the applications. Phases of DevOps lifecycle. The adoption of DevOps practices often involves a series of interconnected activities that span the entire software development and IT operations lifecycle. The DevOps lifecycle is characterized by continuous feedback, collaboration, and the iterative improvement of processes. Different phases of the DevOps lifecycle can be broken down into 8 C's. This is a generalized representation of various phases of the DevOps lifecycle. Plan. In the planning phase, development and operations teams collaborate to define project goals, set priorities, and plan the features and improvements to be delivered. This phase involves aligning development efforts with businesses, objectives, and determining the necessary resources. Code. The coding phase involves developers writing and committing code to version control systems. Collaboration and communication between team members are crucial during this phase. Continuous integration practices ensure that code changes are frequently and automatically integrated. Build. The build phase involves compiling the code, running automated tests, and creating executable binaries. This process is often automated through continuous integration tools, ensuring that the software is built consistently and tested thoroughly. Test. Continuous testing is an ongoing process throughout the DevOps lifecycle. It includes unit testing, integration testing, performance testing, and other tests to verify the functionality, security, and performance of the software. Automated testing is a key aspect of identifying issues early in the development process. Release. Making sure the environment is ready for the updated software to launch successfully is the main objective of the release phase. Deploy. In the deployment phase, validated changes are automatically deployed to production environments. Continuous delivery practices ensure that the software changes are ready for deployment at any time. Operate. The operations phase involves monitoring the performance and health of applications and infrastructure in real time. Continuous monitoring provides insights into system behavior, allowing for proactive issue detection and resolution. Automated scripts may be used to manage and maintain infrastructure. Monitor. Continuous monitoring and logging are essential for capturing data on system behavior, user interactions, and performance matrices. Monitoring tools provide visibility into application and infrastructure health, enabling teams to make data-driven decisions and respond to issues promptly. DevOps use cases. Companies across diverse sectors have adopted DevOps practices. It's important to note that the use of DevOps is not limited to a specific sector, and organizations of all sizes, from startups to enterprises, can benefit from its principles. Some examples of companies that were known for their DevOps adoption are Amazon. Amazon has been a pioneer in adopting and promoting DevOps practices, particularly within its cloud computing division, AWS, that is Amazon Web Services. Amazon heavily emphasizes on CI/CD practices to enable rapid and reliable software releases. Amazon adopts DevOps practices to enhance its service delivery and infrastructure management. Amazon employs a microservices architecture for building and scaling its applications. The company's success in delivering scalable and reliable cloud services is indicative of its effective adoption of DevOps principles. Netflix. Netflix is one well-known example of a company that has embraced DevOps practices to enhance its software delivery processes, ensure high availability, and provide an exceptional streaming experience for its users. Netflix has a microservices architecture where its application is divided into a large number of small, independently deployable services. This enables teams to develop, deploy, and scale services independently, fostering agility and ease of maintenance. Netflix is known for its Chaos Monkey and Simian Army tools, which are part of its Chaos engineering approach. These tools intentionally introduce failures and disruptions into the system to test its resilience and identify potential weaknesses. Netflix's success in delivering a reliable streaming service with millions of users worldwide is a testament to its effective implementation of DevOps practices. Google. Google introduced the concept of site reliability engineering, which combines aspects of software engineering and applies them to infrastructure and operations. Google is a pioneer in containerization technology and is one of the main contributors to the Kubernetes container orchestration system. Google Kubernetes Engine is a managed Kubernetes service that enables the deployment and management of containerized applications. Google's DevOps practices extend to its data analytics and machine learning initiatives. Tools like BigQuery and TensorFlow are integrated into the development and deployment process for data-driven decision-making and machine learning model management. Spotify. Spotify, a popular music streaming service, has implemented DevOps practices to enhance its software development, delivery, and operations processes. Spotify employs a squad model, which is a form of cross-functional team. Each squad is a small, autonomous team responsible for a specific aspect of the product. So, this organizational structure promotes collaboration and shared ownership of the entire development and delivery process. Spotify follows agile principles and Scrum practices for its iterative and incremental development. Agile methods allow teams to respond quickly to changing requirements and deliver software in small, frequent releases. Spotify's emphasis on DevOps principles has enabled the company to maintain its position as a leader in the music streaming industry. Microsoft offers an extensive range of tools and services under the umbrella of Azure DevOps. This suite includes services like Azure Repos for version control, Azure Pipelines for continuous integration and continuous delivery, Azure Boards for work tracking, and Azure Test Plans for testing and release management. Microsoft leverages Azure DevOps Insights for analytics and reporting. This tool provides visibility into development workflows, code quality, and release pipelines, enabling data-driven decisions and continuous improvement. Facebook is known for its rapid and continuous deployment of features and updates. DevOps practices, including continuous integration and continuous deployment, play a crucial role in enabling frequent and efficient releases. Feature toggles or feature flags may be used to enable or disable specific features without redeploying the entire application. This allows Facebook to conduct A/B testing and roll out features gradually. Now that we have an idea about what is DevOps and how it is used in the industry, let's move ahead with the roles and responsibilities of a DevOps engineer. A DevOps engineer is an IT professional who combines software development and IT operations to enhance the efficiency and teamwork of an organization's software development and delivery process. They should ensure fast, reliable, and secure software delivery. A DevOps engineer is responsible for creating scripts and tools to automate various aspects of the software development process, such as code integration, testing, and deployment. DevOps engineers frequently work with infrastructure that's managed through code and act as cloud architects. DevOps engineers also carry out quality assurance software testing to understand the effectiveness of various software tools. They put in place mechanisms to monitor the functionality of applications and gather logs in order to identify and fix problems. Let's move on to some essential technical skills required for a DevOps engineer. Version control. DevOps engineers must be proficient in version control systems such as Git to manage and track changes in code and configurations. Scripting and programming skills. A DevOps engineer must have a basic understanding of Linux fundamentals such as file handling, system administration, text processing, and process management. A strong grasp of programming languages is also important for automating tasks and building custom tools. Cloud services. A DevOps engineer should have cloud computing skills and should have an understanding of public cloud services such as AWS, Azure, or Google Cloud to deploy and manage applications and infrastructure in the cloud. Testing. Proficiency in automation testing is crucial as it guarantees DevOps engineers' ability to detect errors in software projects and products. Containerization. To deploy and manage applications effectively, a DevOps engineer must be familiar with container orchestration platforms like Kubernetes and containerization technologies like Docker. Moving on to the qualifications and certifications of a DevOps engineer. A Bachelor of Computer Science or a related degree that focuses on software development is a minimum requirement for a DevOps engineer. A postgraduate degree will be beneficial. Industry experience in roles that expose you to scripting and programming languages, cloud technologies, and experience in a leadership role may also be beneficial. Some in-demand DevOps certifications required for a DevOps engineer include AWS Certified DevOps Engineer Professional Certificate. So Edureka offers the AWS DevOps Engineer Certification training course that improves technical expertise in provisioning, operating, and managing distributed application systems on the AWS platform. Second, Certified Kubernetes Administrator. Kubernetes certification training by Edureka is curated by top industry experts and will help you clear the official Certified Kubernetes Administrator exam. So this Kubernetes training is live and instructor-led and helps you master key Kubernetes concepts with hands-on demonstrations, which in turn helps you become a certified Kubernetes professional. Microsoft Certified DevOps Engineer Expert Certificate. Edureka's Microsoft Azure DevOps Certification AZ400 course is curated by industry professionals as per the industry requirements and demands. This Azure DevOps training gives you a solid foundation to appear for the Microsoft Certified DevOps Engineer Expert Certification. Please check out the training courses offered by Edureka for these certifications. The link to these is in the description box below. Now let's move ahead with some common tools used by a DevOps engineer. Version control. Git. Widely used for source code version control, Git is the backbone of many DevOps workflows. Git is used to monitor changes in the source code, enabling multiple developers to collaborate on non-linear development. CI/CD. Continuous integration, continuous deployment is a technique that involves automating different stages of app development to regularly deliver apps to customers. Some popular CI/CD tools are Jenkins, an open source automation server that supports building, testing, and deploying code. GitLab CI, integrated CI/CD solution tightly coupled with version control platforms. Travis CI, a cloud-based CI/CD service that integrates with GitHub repositories. Configuration management. Ansible, an open source automation tool for task automation, configuration management, and application deployment. Chef, an automation platform that manages infrastructure as code. Containerization. Docker, a platform for containerizing applications, is one of the most widely used container technologies today. A Docker container image is a lightweight, executable, standalone software package that includes code runtime, system tools, and system libraries. That is everything needed to run an application. Orchestration. Container orchestration automates the deployment, management, and scaling of networking containers. Kubernetes, an open source platform for container orchestration that automates containerized application development, scaling, and management. Infrastructure as code. Terraform is the most popular infrastructure provisioning tool. It is a tool for building, changing, and versioning infrastructure as code. CloudFormation, AWS native IAC tool for defining and provisioning AWS infrastructure. Cloud platforms. Public cloud platforms such as AWS, Microsoft Azure, and GCP offer a wide range of services for building and deploying cloud-based applications. What is CI/CD? CI/CD brings continuous automation and continuous monitoring to apps at every stage of their lifecycle, from delivery and deployment to integration and testing. So these connected techniques are often referred to as a CI/CD pipeline and are used by the development and operations teams. CI/CD is a solution to the problems that arise when integrating new code. Continuous integration and continuous delivery are integral components of the DevOps philosophy, contributing significantly to the efficiency, reliability, and speed of software development and deployment. So let's explore one important CI/CD tool, that is Jenkins. Jenkins is an open source automation server widely used for building, deploying, and automating any project, particularly in the field of continuous integration and continuous delivery. It helps automate parts of the software development process, making it more efficient and reducing manual intervention. So Jenkins is an amazing tool to build a CI/CD pipeline because of its flexibility, extensibility, and strong community support. Jenkins plays a crucial role in the DevOps toolchain by automating key processes and providing a flexible and extensible platform for developing, testing, and releasing software. Its popularity and widespread adoption make it an essential tool for many DevOps teams. Next, let's explore the installation of Jenkins. The prerequisite of Jenkins is that we should have Java, that is JDK, installed in our system. If you haven't installed Java, go ahead and install it. You can refer to the Edureka's Java installation video. First, open the web browser and type Jenkins. Open the first link from the official Jenkins website. Yeah, this is the Jenkins website. Let's go ahead and click on download. So now we are directed to this page. Here we can see the version, download Jenkins 2.4 to 6.1. This is LTS version. So we can download Jenkins using Docker, Kubernetes, or an Ubuntu. Here in this demo, I will be showing how to install Jenkins in Windows. So let's click on this. Yeah, so now Jenkins installer is downloaded. Let's just save it here. Wait for the download. Yeah, so it's preparing to install. Let's now click next. So this is the path where Jenkins will be downloaded. Now here, I am not setting up the password and username right now. So I'm just clicking run service as local system. We'll set it after Jenkins is installed. Next. So this is the port where Jenkins will run, that is 8080. So let's just test if that port is available. So this green tick shows that the port is available. So let's just click on next. So now here we need to paste the JDK link, okay, the path to our JDK. So for that, let's just go, yeah, this is the path. Let's just copy the path of JDK. and let's just paste it here. Click on next. Let this be the default. Click on next and let's press on install. Yeah, once that is done, let's go to this link. Click on this link. So now we need to unlock Jenkins. To unlock Jenkins, we need the initial admin password. So the initial admin password is here, okay, in this link that they have already provided. So let's go to explore. Let's go to our quick access and let's just copy paste this link. Okay, let's just open it using Notepad. Yeah, so this is the password. So let's just copy it and paste it here. Then click on Install Suggested Plugins. So now all these plugins will be installed. Let's just wait for the installation to be over. Yeah, now we need to create a username. So let's keep it Edureka and password. Okay, give your email address as well. Save and continue. Yeah, this is the URL in which Jenkins will run. Let's just save and finish. Now click on Start using Jenkins. Yeah, so this is the Jenkins dashboard and we have successfully installed Jenkins in our system. Now that you have installed Jenkins, we can go ahead and create a CI/CD pipeline. Click on New Item and name it as Jenkins Demo and click on Pipeline, then OK. Okay, then we need to go down and let's try some existing pipeline. So here we have an already existing pipeline, that is Hello World. So this is the pipeline script. So basically a Jenkins scripted pipeline is a sequence of stages to perform CI/CD related tasks that can be specified as code. So it enables you to develop a pipeline script and add it to your code repository so that you can version it. So first we have the node block, okay, that is the pipeline. Then we have the stage block. Here we will define what the pipeline will do. So this step here, it will echo hello world. Okay, that is, it will print hello world. So this is basically a simple pipeline script. Now let's save it and let's click on build now. Okay, so here you can see that the pipeline is getting built, and so these are the different stages. Okay, in the stage view, you can see different stages of the pipeline that we are building. So now here you can see that there is a green tick. Green tick indicates that the pipeline is built. So we'll just go ahead and click on it. Yeah, now we can see that this is the console output. So here you can see that hello world is printed here, that is echoed, and our hello world is a success. Next, let's see how to pull code from a GitHub repository and build a pipeline. So GitHub is a web-based repository of code that plays a major role in DevOps. It provides a common platform for multiple developers working on the same code or project to upload and retrieve updated code, thereby facilitating continuous integration. So Jenkins needs to have a GitHub plugin installed to pull code from the GitHub repository. Also, we need to have Git installed on the local machine. So download the appropriate Git file for your operating system, in this case Windows, and install it into your local machine. So you can execute Git repositories in your Jenkins once Git has been installed on your machine. So to check if Git has been installed on your system, open command prompt and type Git. Yeah, this shows us that Git has been installed in the system. The second thing that you need to make sure is that we need to add the git.exe path to the global tool configuration in Jenkins. So for that, open Jenkins and click on Manage Jenkins. Click on Tools. Under Git Installation, you can see this path. Okay, this is the path to the Git executable. Okay, so for that, to get this path, go to command prompt and type where git. Yeah, so this is the path to my Git executable. So we need to copy this path and paste it here. Okay, and then we save it. Yeah, so that is done. Next, what we need to do is we need to create a repository in GitHub. So this is my repository, CI/CD pipeline. This repository, I created it for the sake of this demo. So, and you'll also have to add a file that is Jenkins. Okay, so this is a document named Jenkins. So the Jenkins file is a text file that includes the description of a Jenkins pipeline. Okay, so this is the pipeline code. So the stage block comprises a number of stages in a pipeline showing the Jenkins pipeline flow. So here there are 3 stages: build, test and deploy. So each stage will print building example. The first stage will print building example. Second will echo testing example, and the third deploying example. So now that everything is set, let's go ahead and build the pipeline in Jenkins. Okay, so click on new item, name it as Jenkins Demo 2, and then click on pipeline and click on OK. Yeah, here we need to click on GitHub project, and for the project URL, we need to go to the GitHub repository and click on code. Here we have the HTTPS link. Copy that and paste it here. Then go down and also enable this option, that is GitHub hook trigger for GITSCM polling. Now, once that is done, go to pipeline and pipeline script from SCM. Yeah, so now we need to choose our SCM, which is Git, and the repository URL will be the same thing that we had copied. Okay, so control paste, and then here under the branches to build, replace master with the asterisk. Once that is done, you also need to change the script path to Jenkins and save it. Okay, so now our pipeline is ready. Now we'll have to build it. So click on build now. Yeah, now we can see that our pipeline is getting built. So these are the different stages. You can see the progress here. Yeah, now the pipeline is built. We can see the green tick. So click on that. This shows us the console output. So you can go down. You can see if the statements are being printed. Now you can see that building example, testing example and deploying example. The 3 statements are being echoed, that is being printed here. So now we have successfully created a pipeline in Jenkins. DevOps is a revolutionary approach to software development and IT operations that prioritizes collaboration, automation, and a culture of continuous improvement. As technology evolves, DevOps principles remain relevant in ensuring efficient and reliable software delivery. I hope you got an idea about DevOps. Now, since Jenkins is installed in your system and you have an idea about how to create a pipeline in Jenkins, go ahead and explore the different functionalities of Jenkins. Make sure to like and subscribe to our YouTube channel. Thank you for watching and keep learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!